Today we're here to talk about IntervalZero's RTX and how it transforms Windows into a real-time operating system. The first question you might be asking yourself is, why do we even need this? So let's take a look here. There's actually many high-performance, high-precision applications that actually require hard real-time performance, and they also want to leverage the full Windows experience. If you look here, for example, industrial automation, media workstations, medical imaging. This is just a small sample set of these type of applications that again require hard real-time determinism, and they want a very powerful UI like the full Windows experience. So a lot of times today these applications actually do that. However, they do it by combining multiple architectures together and a lot of complex tooling. So they might, for example, have Windows on one part, but then they have things like DSPs and FPGAs to actually deliver the real-time component. If Windows were actually a real-time operating system, that would actually greatly simplify and streamline the development of many of these products. Okay, so let's actually get into this a little more. So Microsoft Windows. Windows is a world-class general-purpose operating system. It is not a real-time operating system. So although you have a powerful UI and tooling, you lack the real-time credibility and the performance that's needed for a lot of these high-precision, high-performance apps. However, when we now combine RTX with Windows, RTX now transforms Windows into a real-time operating system. So still powerful Windows experience, but now RTX delivers hard real-time capabilities. And also, RTX has been doing this transformation of Windows for over 10 years worldwide. Now let's take a look at the Windows operating system and talk about how RTX transforms this. So first, let's look here. At the base of it all, we've got multi-core x86 hardware, so pretty typical motherboards. In this case, it's a dual core. Here we have the Windows HAL layer, or hardware abstraction layer. Next, on top of that, we have the Windows kernel and device drivers. So this is actually where the Windows scheduler lives. And then now, all of this is actually inside of kernel mode. If we go above this line, this is now the user space. So this is where the Win32 subsystem lives. And then finally, customers or app writers, this is where the actual Windows application sits on top. So this is actually the overall Windows architecture. So this is a great thing because it delivers, again, the full Windows experience. We've got very powerful tooling, large software install base, extremely powerful UIs can be developed. It's enabled by multi-core x86, so very standardized processors, and that leads to supporting commercial off-the-shelf hardware. So you can use off-the-shelf motherboards. No longer do you need to make any custom hardware. However, the drawback is this is not real-time. So as powerful and as capable Windows is as an operating system, it does not deliver real-time performance. So now let's actually show how RTX, when added to the equation, transforms Windows into a real-time operating system. So again, we take the same Windows as far as kernel here, all the same pieces, but usually what you'll find in many instances is you'll have a multi-core implementation, and in this case we have a dual core. And a lot of times you'll have a core sitting idle. So Windows is more than happy as far as sitting on one core. So in this case, what we want to do is dedicate this additional core here to do real-time processing. So let's say now once we install RTX into the situation, we can do that. We're actually going to take this core away and dedicate it for real-time processing. And when you install RTX, just FYI, not only are you dedicating for real-time processing, because RTX supports symmetric multiprocessing, you can dedicate up to 31 real-time cores for hard real-time determinism. And so let's show how this kind of builds out. So now we have this real-time core. RTX actually has its own hardware abstraction layer. So this RTX HAL extends the Windows HAL, so it doesn't replace it. So this actually, by having this separate or extended HAL, this provides applications or your real-time apps access to high-resolution timers down to the 1 microsecond level, and also direct hardware access. So as you develop real-time applications, they can access the PCI bus directly, as well as a number of many interrupts that you might want in real time. Okay, so there's the RTX HAL. Next on top of that is the RTX Subsystem. So this is where the real-time scheduler exists. So this is the RTX scheduler. So this separate real-time scheduler runs on this core 1 or the second core, and it's totally independent from that of the Windows scheduler. So this is actually how RTX is able to guarantee determinism. We have a separate real-time scheduler that Windows cannot interfere with, and so any real-time functions can be scheduled and be truly deterministic down to, for example, the 1 microsecond level. Also, the thing you should know about the RTX scheduler or the subsystem is that it supports true multiprocessor affinities. So as you create threads and processes, this is a single core real-time instance, but if we had, for example, up to, say, a dozen cores or even 4 cores, you can assign threads to specific real-time cores so you can truly dedicate real-time performance if your system so desires. And then finally, you should know about the RTX subsystem is the fact that it's Win32 based. So all of the APIs are very similar to what you find in a standard Windows application. So as you're moving applications back and forth, for example, a non-real-time app and you want it to be real-time, it will be fairly seamless to do so using a common API set. Okay? So now let's get to the final piece here, and this is where you as a user will actually write your real-time applications. So this is the RTX Process or real-time app, and so this application now has access to the scheduler as well as all the way down to the true hardware itself through the hardware abstraction layer. So now your applications that you write have direct access to timers and interrupts, for example. So that is very powerful, and again, that's how the system delivers real-time performance. Also, you should know is that all of this real-time applications here under RTX are built and debugged under Visual Studio. So the same powerful tooling that you're using here to build your Windows environment, you're actually using here to build your real-time environment as well. So this greatly simplifies your tooling. No longer are you having separate tool sets. You're actually using a single integrated development environment, and that's Visual Studio. And then finally, for example, if you need hardware that's outside of, for example, some basic timers, you actually have the capabilities to build real-time drivers under RTX that can support your real-time apps. So because you have direct access to the PCI bus, you can create these real-time drivers, again, to be extremely precise, at very high rates. And any drivers you write here, they do not interfere or go through any of the Windows kernel. So again, that's by keeping it separate here is how we get the hard real-time determinism. Okay, so the last question you might be asking is, now I have my real-time applications, I have my Windows applications, how do I actually get them to communicate? The final piece is communications. So if you look here, you have your Windows applications and you want to communicate with your RTX, a real-time app. There's actually a set of real-time APIs. It's nicknamed RTAPI. So you have some nice APIs here that you can actually use for synchronization between these two environments. So they can be, for example, events or semaphores. Once you have those synchronization events, the next question is, don't I want to exchange data? Well, the way the exchange data in this system is we have shared memory. So RTX shares memory with Windows. So we have a large area here of non-paged memory that you can use to exchange large amounts of data between Windows and RTX. So this is pretty seamless because you're actually on the same processor, the same chip that you're able to share memory. Traditionally, these might be 2 separate processors on the same board, for example. You usually, to have communications, you'd have to have some dedicated serial port or some sort of dedicated peripheral used to communicate, which creates a lot of complexity and a lot of maintenance. Now we just have some APIs as well as some shared memory to do the synchronization as well as the data exchanges. Okay, so this is the Windows plus RTX as far as architecture. So this is how RTX transforms Windows into a real-time operating system. Okay. So we've talked about this in a good amount of detail now, in the sense that the RTX and Windows, this is how we make the real-time operating system. It's all based on multi-core x86 hardware, leveraging Intel and AMD's multi-core roadmaps. Again, combining Microsoft Windows and RTX transforms Windows into a real-time operating system. And the thing you should know is these components are actually part of a larger platform, and that's the RTX RTOS platform. And so the other pieces to that include communications. So we kind of glossed over this, but in this case we're talking about things like real-time Ethernet. So you could be using, for example, EtherCAT, a Profinet And this actually extends into other communications real-time, for example, CAN buses or other data acquisition cards and other types of COM. So there's a lot of additional I/O that you can now put into the platform. And then you as a customer will implement your applications and IP up at the highest level, leveraging all of these components of the RTOS platform, and you're doing it all under a single integrated development environment, and that's Visual Studio. Okay. So hopefully you found this video helpful and showed kind of how RTX transforms Windows into a real-time operating system. If you go to our website, you'll see a lot of other videos that go into a little more detail about the RTX RTOS platform and how it can help you in your system. So hopefully you found it helpful, and thanks again for tuning in.